Okay, so now we're going to look at how do we deal with significant figures when we're doing calculations, all right? So believe it or not, there's a reason why we went through all we went through just now concerning determining the number of significant figures and making distinctions between measured numbers and exact numbers. All these things will come into play when we're looking at dealing with rounding off our final answer to the correct number of sig figs when we're doing calculations, all right? So the first thing I want to talk about here is that when we're doing these type of calculations, we need to base the number of digits in a result on measurements and not on known values, all right? So we have to look at the number of significant digits present in a particular measured value. And that would involve or would be involved in looking at things like the atomic mass, accurately known densities, and other physical constants, all right? Now, let's talk about the actual mathematical operations involved and how do we deal with significant figures in these situations. So when we're multiplying or dividing numbers, then what we need to do in terms of ending up with the right answer is that we need to record the right answer to the same number of significant figures in the result as the data with the fewest number of significant figures, right? So basically what this is saying is that when you're multiplying and or dividing numbers, your final answer, the number of significant figures in your final answer must be the same as the number of significant figures involved in the calculation with the fewest number of significant figures. Now, when it comes to addition and subtraction, the rules are a bit different. What the rule in this case says that in your final answer, the number of decimal places in the final answer will be the same as the data with the fewest number of decimal places, all right? So when it comes to multiplication and division, we look at the number of significant figures and we record the final answer to the lowest number of significant figures of the numbers involved in the calculation. When it comes to addition and subtraction, we round off your final answer to the lowest number of decimal places of the number involved or the data involved in the calculation. All right, so just to illustrate this, we're going to look at these two examples. So the first example says, in an experiment, a lab experiment, a teacher wants to divide all of a 453.6 gram sample of sulfur equally among 21 members of her class. How many grams of sulfur should each student receive? All right, so it's a pretty straightforward, question. You're given a total amount of a particular substance, sulfur, and you want to divide it equally, which means that basically what you need to do is divide the 453.6 grams by the 21. But we have to look at the number of sig figs involved. So let me get out of this here and let me open up this writing. The last time I did this, it didn't work. Let's see if it will work this time. Let me erase these markings here. And let me go to my pen function. Okay, let me see if this would work. Okay, it's not working. All right, so sorry about that, folks. I don't know what's going on with this particular application. So what I'm going to do is open up a new PowerPoint document, blank document, and write on that. So let me get rid of this here, get rid of this here, and then let me go full screen, and then let me choose my writing, my pen function. Okay, so in this question, they gave us 453.6 grams of sulfur, and you're to divide it evenly among 21 students, right? Oops. Okay, so basically, all you have to do is pull your calculator out. Let me do this here. So 453.6 divided by 21. Okay. Now, let me do this again. 453.6 divided by 21. Okay, so what I got on my calculator screen is 21.6. So it's going to be 21.6 grams per student. All right. Now, you'll notice that this is a measured number, right? And the number of significant figures here is 4, right? But here, this number here is an exact number because we got this number by counting. So therefore, the number of significant figures represented here is infinite, right? So this has an infinite number of significant figures. All right? According to the rules that we just discussed, when you're dividing and or multiplying, you round off your answer here to the lowest number of sig figs. All right? We have an infinite number of sig figs here, and we have 4 sig figs here. So that means that this number here must be expressed to 4 sig figs. As it is right now, it's expressed to 3 sig figs. So how do we express this to 4 sig figs? Very simple. All we have to do is rewrite this, but add a 0 at the end. All right? And now this number here is expressed to 4 sig figs. All right? So this would be the correct answer, which reflects the true, the highest precision to which this number can be recorded. All right? So that's how you take into account the number of sig figs when you're dividing two numbers. In this case, we're dividing a measured number versus or by an exact number. In this case, it's a measured number which determines the number of sig figs that you'll end up with in the final answer. All right? Okay, so that's that example. Let me go back to the PowerPoint here. So the next example, you're given this question. Perform the following calculation and round off the answer to the correct number of significant figures. And you're given these numbers here, all right? So let me open up or go back to the PowerPoint that I was just working with. And let me erase. Well, maybe I don't have to erase. Let me go back to my pen function here. And let me just draw a line across. Okay, so basically you're adding these numbers. You're adding 49.146 meters plus 72.13 meters, and then you're going to minus 9.1434 meters. All right? So again, you go to your calculator, 49.146 plus 72.13, and then we minus 9.1434. And according to my calculation, on my calculator display, I end up with 112.1326 meters, all right? Now, in this case, we're doing a combination of addition and subtraction, right? And according to the rules, when we're adding and or subtracting numbers, we round off your final answer to the lowest number of decimal places of the data involved, these three numbers here, right? So we have to examine these three numbers and determine which one has the lowest number of decimal places. This number, the first one, has 3 decimal places. This number here has 2 decimal places. And this one here has 4 decimal places. So that means that in this case, we have to round off the answer to 2 decimal places. So therefore, in this case, the answer becomes 112.13 meters. So this would be the final answer, which again reflects the correct level of precision in terms of the result based on the calculation that we did over here. All right? Okay, so that's as far as those examples are concerned. So let's move on now to a discussion of the problem-solving method, which involves unit conversion. All right, so what we're looking at here is how do we convert from a value from expressed in one unit to another unit, right? So first thing we need to understand when it comes to these conversions is what is stated here. Multiplying a quantity by 1, let me go back to full screen. Multiplying a quantity by 1 does not change the quantity, right? And then the second thing that is being noted here is that the same quantity or unit in both numerator and denominator of a fraction will cancel. That will be involved, as you're going to see in the examples that we're going to look at shortly. Now, before we look at an example of how do we do conversion, we have to point our attention to the relationship between different units. As you can see in this table, this is just a small sample of different types of, relationships between different units. So for example, this is the relationship between the kilogram unit and the pound unit, right? 1 kilogram is equal to 2.205 pounds. And here's the relationship between the gram and pound unit. And here we have some other relationship with respect to length. 1 meter is equal to 39.37 inches. And here we have relationships in terms of volume. 1 liter is equal to, for example, 1.057 quarts, all right? So here we have different relationships between the metric units and non-metric units, kilograms to pounds, grams to pounds, grams to ounces, meters to inches, and so on, all right? So we can use these relationships to do conversions from one particular unit to another. So let us focus on the relationship, for example, between the inch unit and the centimeter unit. So 1 inch is equal to 2.54 centimeters. And let me just say that that relationship is by definition, as stated here. US inch is defined as exactly 2.54 centimeters, right? So this is an exact relationship. All other relationships between metric and non-metric units are basically equivalences that are rounded off, which means that they're measured values, all right? So we can write down what we call two conversion factors, which represents this relationship, right? You can have 2.54 centimeters divided by 1 inch, or you can have 1 inch divided by 2.54 centimeters, right? And when you divide one by the other, that would be equal to 1, all right, in each case, all right? So if you want to convert from inches to centimeters or from centimeters to inches, you can use either one of these conversion factors. In fact, you would use this one if you want to convert from inches to centimeters, and you would use this one if you want to convert from centimeters to inches, right? So basically what we do is that we multiply the quantity that we're trying to convert from by either this conversion factor or this one, and then we get the answer, all right? So which one do you choose? Well, the answer is right here. Use the one that cancels the unit that we do not need and leaves the unit that we want, all right? And you're gonna see how, I'm going to do an example to show you how that works. So let's say you want to convert 36 inches. Let me just go here and then do this and then do that and then do that. Okay, so let's say you want to convert 36 inches to centimeters, right? So the way you set this up is that you start off with the 36 inches, all right? And now you have to multiply this by a conversion factor, which represents the relationship between the inch unit and the centimeter unit. Now remember, 1 inch is equal to 2.54 centimeters. So here we're going to put 1 inch down here and 2.54 centimeters above. And this is a setup because we want to eliminate the inch unit, and the only unit remaining will be the centimeter unit. All right, so get my calculator out, 36 times 2.54, and the answer I got on my calculator will be 91.44 centimeters. However, we need to round this off here appropriately. This here, we have two significant figures here, and this here, that conversion factor is an exact relationship. So therefore, we round off the answer here based on the fact that we have two significant figures here. So this becomes 91 centimeters. And that would be the final answer. All right, so that's just a short example showing you how you convert from one unit to the other using the appropriate conversion factor, which represents a relationship between the units you're converting from and the units that you're converting to. All right? Okay, so let's move on to some other examples. Get out of this here. Okay, so here we have two examples. So this question, well, the first one is asking for the length in millimeters of a 12-foot rod. The length in millimeters of a, 1.25 foot rod, my bad. Okay, so again, let me get out of this here, go to this PowerPoint here, and make this full screen, black ink. Okay, so basically this is what you're given. you're given 1.25 feet, and you're asked to convert this to millimeters, all right? Now, basically what we need to do is try to find out the relationship between the foot unit and the millimeter unit, all right? Now, the tables that I've provided in Canvas does not give you a direct relationship between these two units. However, we can, through a series of relationships, ultimately end up with the relationship between the millimeter unit and the foot unit. Firstly, I'm going to say here, and we all know this, that 12 inches is equal to 1 foot. All right, that's the first thing I'm going to put down here. And we also know that 1 foot, I'm sorry, 1 inch, my bad, is equal to 2.54 centimeters. We talked about that earlier, all right? And then we can say that 1 centimeter is equal to 100 meters. And then finally, we can say that 1 millimeter is equal to 1,000 I'm sorry, these two are incorrect. It's 100 centimeter is equal to 1 meter, and 1,000 millimeters is equal to 1 meter, all right? So these are the relationships we can use to convert from feet ultimately to millimeters. This should be millimeters, all right? So how we're going to set this up? Well, we start off with the 1.25 feet, and then we multiply this by, we convert inches, right? So we're going to have 12 inches above as a numerator and 1 foot below, so that this unit cancels out with this unit. So we would have converted successfully from feet to inches. The next step is to use this relationship to convert from inches to centimeters. So 1 inch is equal to 2.54 centimeters, all right? And then the next conversion factor we're going to use represents this relationship going from the meter unit, or I should say the centimeter unit, to the meter unit. So the way we represent that is that we're going to have 100 centimeters down here and 1 meter above, so that this goes with that. And then the final conversion factor is where we have the relationship between the millimeter unit and the meter unit. So in this case, we're going to have 1,000 millimeter above and 1 meter below, all right? So that this unit cancels out with that unit. Okay, now before we do the calculations, I just want to establish the fact that these conversion factors all represent exact values because they're all by definition. So I'm just going to put exact right here, right? These are all exact numbers. And what that means, therefore, is that when you do your calculation, the final answer will be rounded off to the same number of sig figs as the 1.25 here, which, by the way, is 3 significant figures being represented here. So therefore, the final answer here will have to be rounded off to 3 significant figures. So let me do the calculation. So 1.25 times 12 times 2.54 divided by 100 times 1,000. And I just realized that this should be 1,000 here. So let me just scratch out this 0 right here. All right. And according to my calculations, this works out to be equal to 381 meters, which is also, I'm sorry, this should be millimeters. So this should be millimeters right here, which is also expressed to 3 sig figs. All right. So that's basically how we do that. All right. So as you can see here, in some cases where you're doing conversions, you have to use a series of conversion factors to get from what you're given to the expressed units that you're trying to work towards. All right. And in order for you to do that, you have to know the different relationships between the different units in each step. So you can use what you know. For example, everybody knows that 12 inches is equal to 1 foot, 3 feet is equal to a yard. But also you can use the values that are provided in the tables that I've given in Canvas, all right? So that's what you're going to use in order to do problems like this one. Okay, now the next example is, let me see here. They gave you this box right here, a cuboid shape, and the question is asking, what is the volume in cubic centimeters of the block of wood pictured here? So you have the height, the width, and the length, 4.41 inches by 4.13 inches by 7.36 inches. All right, so let me go back to my blank PowerPoint here. So basically, again, this is a simple calculation. The volume, whoops, let me go back to full screen here. Go to my pen function. Okay, so the volume will be equal to the length times the width times the height. The length would be equal to 7.36 inches. The width would be 4.13 inches. And the height is 4.41 inches. Again, very simple calculation. So it's 7.36 times 4.13 times 4.41. And according to my calculations, this works out to be equal to 134.049888. That's what I end up with on my calculator display. And the units for this would be inches cube, all right? And that's because we're multiplying inch by inch by inch in terms of the units. So the unit for the volume in this case would be inches cube. Again, when we're multiplying and or dividing, in this case it's all multiplication, what we have to do is round off according to the lowest number of significant figures. And it turns out that these are all expressed to 3 sig figs, which means that we have to express this number to 3 significant figures. So in this case, the answer works out to be equal to 134 inches cubed. And that's how you do that. All right? Okay, so that's basically how we will tackle those two problems. All right. Again, if you have any questions, feel free to contact me so that I will be able to help you with any issue you may have in understanding these questions or problems. All right? Okay, so let's move on now to the next slide, which is another example. It says a commonly accepted measurement now used by dietary specialists in assessing whether a person is overweight is what is called the body mass index, which is based on the person's mass and height. It is a mass in kilograms divided by the square of the height in meters, right? So therefore, the units of BMI would be kilograms per meter squared. Generally speaking, if the BMI exceeds 25, a person is considered to be overweight. So this question is asking, what is the BMI of a person that is 69.0 inches tall and weighs 158 pounds, all right? So according to, I should be able to do it here. So the BMI, let me write this down. Oops, sorry. Okay, BMI. According to what was stated here, the definition of BMI is the mass of the person divided by the height of the person squared, all right? So in this case, the mass is 158 pounds for this person, and the height of this person is 69.0 inches. Now, what we need to do is convert this to kilograms per meter squared. All right? So how do we do that? Okay, so let me show you down here. I'm going to start off with the 158 pounds down here, divided by, oh, by the way, this should be squared. Very important. That should be squared. Okay. So this would be 158 divided by 69.0 inches, all squared. All right. So what you can focus on is convert first from pounds to kilograms, right? So in order for us to do that, we have to multiply this by the appropriate conversion factor. And let me go back to the table here. So if you go to the table, you'll see that 1 kilogram is equal to 2.205 pounds. So I would put 1 kilogram above here, and put 2.205 pounds below, all right? So that the pound units will cancel out here and here, all right? So you're left with the kilogram units. Then I would focus on converting from inches squared to meter squared. So that means I need to find some way of doing that conversion. What I would do in this case is first convert from inches squared to centimeter squared. Now we know that 1 inch is equal to 2.54 centimeters. So the way I would set this up is that I'll put 1 inch above as a numerator here and 2.54 centimeters down here. But in addition to that, I would square this because the inch unit here is squared, which means that I need to have an inch squared unit here so that this would cancel out with this, all right? So what I'll be left with up to this point is centimeters squared down here. But we cannot stop there because remember the aim is to get to meter squared. So the next step would be that I would, in this conversion factor, write down one that is representing the relationship between the meter unit and the centimeter unit. And we know that 100 centimeters is equal to 1 meter. So I'll put 100 centimeters above as a numerator and 1 meter below as a denominator. And again, I'm going to put squared right. I'm going to put this squared because you want this, you want this centimeter squared unit cancel out with this centimeter squared unit, right? So you'll be left with a meter squared down here. So whatever your final answer is going to be, it's going to be expressed in kilograms above the meter squared unit, all right? So the next thing we need to do here is our number crunching. Let me do that now. 158 divided by 69 squared. Okay, divided by 2.205 divided by 2.54 squared times 100 squared. And according to my calculation, I'm going to end up with a rather long string of digits, which we need to round off to 3 sig figs. And the reason why we need to round off to 3 sig figs is because we have 3 sig figs here, and we have 3 sig figs down here. Here we have 4 sig figs. Here, this relationship is exact. And the same is true for this relationship here. So we need to round off our answer to 3 sig figs. And therefore, when I do that, according to my calculator, the answer becomes 13.3 kilograms per meter squared. All right? So that's basically how that is done. Okay. I think I'm going to stop here. And the next video will be the last one for this chapter, which deals with density. All right? So until next time.